All right. So good morning, everybody. Don't know what's going on back there. That looks attractive. Oh, well, it's gonna look ridiculous all day. All right. So still kind of waiting while everybody else trickles in, or hopefully everybody else. Let's see. Go ahead and type our reminders. All right. So test number 4 is up, and it is available until this Sunday, basically through this Saturday evening at 11:59 p.m. So it's going to be in before Sunday. And you've got your attempts. I highly suggest you take it sooner rather than later, at least for the first attempt. That way, if there's any big issues or problems, you're aware of it ahead of time. And I will be having kind of extended office hours for the tests. Basically, all day on Tuesday and Thursday, I will be hanging out. I'll be on the computer doing other paperwork and stuff. So if you need or would like to take the test so that you can ask me a question during those times, I highly suggest it and welcome it. You can have me on voice chat in that office hours, or you can send me messages or a picture of your test, something like that. It's much better than email because it's a lot quicker, and the thread of all the messages that we've sent is right there, and attaching things you just drag it and drop it. So in my opinion, it's much easier, but I will also be available through email and stuff like that. Okay, so there's that. Okay. Today we're going to be kind of doing I guess review. So what of the last couple weeks would we like to go back over? What things would we like to talk about? What would we like to see?
Can it be something from the test already?
I mean, I will make up my own version of that problem, but yeah, I mean, it could be, if you've already taken the test, you can ask me about a question from it, and then I'll give you an answer that tells what covers that question, but doesn't like give you that.
Okay. Like I think it was something like if is why how to wait.
If you want to give me the little code, it says like LAR call at 10.2.3.041 or something. If you want to give me that, just the numbers at the end, I can look it up.
Well, I have to go to my computer.
That's fine. Well, if you remember what it says, then we can do that too.
I'll go to my computer.
Let's. So some things that you might want to understand is let's change color. That green's kind of washing out. You find it yet?
Open it back up after I already took it.
I think you can. Do you remember which question it was? I might be able to look it up.
Oh yeah, it basically was just like, who you talking to? Me? It's saying basically just seeing how is X a function of Y or Y is a function of X. Like how if it had like a chart of numbers. So it's like some X functions and Y functions, and it was just like yes or no. And then it had like one was like an equation, and it had like the square, like the cube root or something plus something, and seeing if it was like a function. It was the first.
So you had a question about. It says determine whether the relation represents y as a function of x?
Yeah, something like that.
Okay. All right. So let's remember some of the qualities of a function. So dying. So in order for something to be a function, let's just say x plus 4. So this is a linear function. Okay. So what are some of the rules about functions? There's a test that we can do for functions. What is that test?
I don't know the test, but is it like it can only cross like once?
Yeah. So it's that one. What is? Who else can help? What is that test called?
Oh, is it the horizontal?
Other one.
Of vertical?
Yeah.
Oh, vertical test, vertical line test. Something.
Yeah. So what the vertical line test says is that if you draw a vertical line, the vertical line cannot intersect that graph 2 or more times. It can either do it 0 times or 1 time. The other way of saying that, if you're talking about the numbers, is no input I'm sorry. No output comes from, how do I want to say this for you? If you draw a vertical line test and it fails, then that means that this x value could give you this y value or this y value. So no 2 outputs comes from 1 input. So if you draw a vertical line and it goes through twice, that means that this x value could give you this number or this number. So to be a function, you cannot have the same input with a different output. So if we were to draw a table of x's and y's, you could have 1, 2, 3, 4, 5, 4. Let's say 7, 8, 9, 10, 11, 12. So because this 4 makes a 10 and 4 makes a 12, then it's not a function.
Okay.
So this is the equivalent of failing that vertical line test, is if you have 2 different outputs from the same input. But if you have no repeats, then it is a function. So you could have the other way, where you have two different inputs give the same output, though. So if you had an equation like y equals square root of 9 minus x squared, this is a function because if you put -3 in there, you get, or let's do -4 or something. No, we can't do -4. -2. So 9 minus -2 squared is square root of 5. But you could also put +2 in there and you get the same answer, but that's okay. Because that doesn't break our rules of a function. Sorry, going off the page a little bit. So those questions were just all about what makes a function, what rules have to be followed. And the main one is this vertical line test thing, where if you have a single x value that gives you two different y values, then it's not a function.
Okay.
Good question.
Can I ask more?
Absolutely, please do. Otherwise, nobody else may ask a question.
Okay. How to find the min and maximum?
All right. Hold on. All right. So finding the min and max. So let's see. So I'm trying to figure out, just looking through your test where you had mins and maxes. So the minimum, there's two different kinds of mins and maxes. There's absolute, and local. So if we take a basic graph, we'll call this y equals x squared. So let's find the absolute min, max, local min, max. So what is the absolute maximum of this graph? It's the largest value that y can get.
Infinity? Negative and positive?
So the absolute max is y equals infinity. I agree with that. What about the absolute minimum?
0.
0. Yep, very good. Now, what about local maximums or minimums?
What does that mean?
So absolute means it's bigger or smaller, or I guess higher or lower than all of the other numbers in the entire thing. Local means that it's bigger or smaller than the people directly around it. So infinity is not a local minimum or maximum. You could kind of say, because there's nobody to the right or the left of him. So like if you kept going to infinity, assuming you could even get there, there's nobody to the left of him. So that's not really an absolute, that's not really a local minimum or maximum. But are there any points who are smaller than the people next to them or bigger than the people next to them?
Can you like do some points?
So the only one is this one. He is lower than these guys and lower than these guys. So all right. Are there any points who are bigger than the people around them?
The top?
I'm sorry?
The ones at the top?
So, but at the top, it keeps going. So there's nobody to the right of the biggest person up here. The biggest person is at infinity, but there's nobody on the other side of him because he would be bigger and then he would be the biggest point. So local minimums and maximums graphically happen at dips or peaks. Are there any peaks on this graph?
No.
No. Not applicable, none, whatever you want. So this is the difference between absolute and locals is, and sometimes there is overlap, for sure. If we took a slightly different graph, if it didn't look like that, if it looked like, I'll draw it over here, if it looked like this, then this is a local maximum because it's at the top of a hump, but it's also the absolute maximum of that graph because it's the highest point overall. So it can be both, but a local can only happen at a hump, and the absolute can really happen anywhere, but usually it happens at the far ends. Does that answer your question?
Mm-hmm.
Okay, good, good. What else you got?
It was like the vertical, like, yeah, vertical something.
Vertical.
I think, I don't know, it was on the same, I think it was on the same question as the max and the min. It was like, it had a graph and it was like, what's the, or is it vertical? I don't know.
So on your max or min functions, there's nothing else on there.
No.
So one thing that we may want to talk about is parent functions. Because that was kind of a big step. So what is the parent function of this?
Wait, do you just plug
It's
oh wait,
easier than that. What is the most basic version, or what kind of function is this? We had a couple of basic types we talked about. Starts with an L.
linear?
Yeah, this is a linear function. But what is the most basic linear function?
Y equals X.
So the parent is y equals x. What about y equals 5x minus x squared plus 2. What is the parent function of that?
Oh, y equals something plus C.
Nope. You're thinking about it too hard.
What? Oh, you already put it up there.
Well, I was putting it up there while you were thinking about it. So the parent function is the most basic version of that thing. For polynomials, it's very easy. You look at the number, you look at the thing that has the biggest exponent, and that's the kind of function it is. The biggest exponent here is a 2, so it's y equals x squared. The biggest exponent here is a 1, y equals x. You could have y equals 1 over x minus 5. The simplest version of that is y equals 1 over x. So remember, like, parent functions are supposed to be a very simple thing to do. To find the parent function of another function should be very simple. What you see in here, though, is it asks you to find the parent function and then describe transformations that happened to go from the parent function to the other function. So let's do that. So this is the parent of this one. We need to figure out what do we have to do to this to make it this one. Okay? So what do we have to do to this to turn it and make it look like this?
Y minus 5 divided by 3.
Y minus 5 divided by 3.
Wait.
So you're kind of on the right track. Being able to do that to the other side is fine. But you could kind of think about it as in-between steps. So let's take care of the 5 first. So you said y minus 5 equals x. What transformation do you replace y with y minus 5? What transformation did you do? So we took y and we turned it into y minus 5. What transformation is that?
Subtraction.
That's the mathematical operation is subtraction. But there's a list of transformations that we have. There were shifts, which is where you just push it up, down, left, right. There were stretches and squishes, where you make it smaller or bigger, or taller or shorter. And then there were reflections, where if it was faced up, you do a reflection and it faces down.
So is that a shift?
It's a shift, and in what direction?
Minus 5. So up.
By how much?
5.
Very good. Up by 5. So we take the parent and we shift the parent up by 5, and it gives us this. Then we want to go from there to y minus 5 equals 3x. So that transformation is x to 3x. What is that called? First of all, what kind of transformation?
Is it a What you said, squish and what? Squish
and a stretch? Yeah, it's one of those. Which one?
Stretch. Wait, I don't know.
It's the what? Why? This one was subtraction, but you went up. Why did you go up if it's subtraction?
Oh, the opposite. So is
Because it's the opposite. What?
It's a squish.
It's a squish, because we're making the graph bigger, which makes the line itself look smaller. So this is a squish. And in what direction?
Down. I mean, oh wait.
So
Inward.
what? Inward. That's the word that I would pick for this, is in. But it means in. You could also say that this is in, but I would say that this is down. But it's kind of vague, I guess. So squish in by, we'll say, factor of 3, which just means it's a third as big. But yes, very good. So we do those two things, and we can take y equals x and turn it into, just by moving this thing around at the end, y equals 3x plus 5. So very, very good. Figuring out which stretch, which squish is where is, you know, kind of important. So let's do a simpler one, even though it looks less simple. What is the parent function of that?
Y equals x cubed.
Very good. And what transformation
Shift.
Okay.
Up. Wait. Yeah. Shift up 9.
Let's see. So a shift up by 9 means we go from y to what?
Y minus 9.
Y minus 9. So that means that we take y equals x cubed, and it becomes y minus 9 equals x cubed. We can add that over, and we get y equals x cubed plus 9. Very good. So this is just the x cubed graph moved up by 9. So I will go ahead and, in my last minute or so, I will give kind of a warning, a caveat. Lines can be confusing. X cubes and squares and stuff are usually not as crazy, but if you had y equals 2x, and I asked you what shift this was, you could say that you take y goes to y over 2, or x goes to 2x. Because if you did y is y over 2, you get y over 2 equals x, which is the same thing as y equals 2x. Over here, you get y equals 2x. It's the same thing with shifts. If I had y equals x minus 2, I'll put it. I could say that that is y goes to y plus 2, or x goes to